Alright, synthetic division is another way to divide polynomials, but you can't always use synthetic division. You're only going to be allowed to use it if the divisor is just a 1x to the first. If it has a coefficient here, or if it has an exponent, you won't be able to use synthetic division. So what we're going to do synthetic division is you take, basically you set the divisor equal to 0 and you solve. So you're going to use x as -2, and that value goes on the outside of the box, and then the coefficients of the dividend go on the inside. So this is a 1 here, -14, +51, -54. Don't forget, use the signs with the coefficients as well. And what I do, always bring down that first term, so that's going to be a 1. And then what I'm going to do is I'm going to take this value that's on the outside, -2, multiply it with what's in this line here. So -2 times 1 is equal to -2, and then that's going to go up there. So that becomes -2, and then combine, -14, -2 becomes -16. And then multiply, -2 times -16 becomes +32, and that's going to go up here. And then I'm going to combine, and that becomes 83. And then I have -2 times 83, and that's going to be -166. And then combine, and that becomes -220. So all this is multiplying and combining. You're not going to have to show these steps here. I was just showing you how I'm getting these numbers in that line. And once you're left, let me erase these. What you have left down here, these are your coefficients to your new polynomial, and this last one is your remainder. And the new polynomial is going to be 1 degree less than what you started with. So since this was a cubic, that means my new polynomial is going to be a quadratic. So I have 1x squared minus 16x plus 83. And the remainder is -220, and I'm dividing that by the divisor, which originally was x plus 2. So x plus 2. And that's my quotient. Okay, the next one we're going to do is the remainder theorem. And we're going to use synthetic division to use the remainder theorem. But what the remainder theorem says is that if I take a polynomial p of x and divide it by x minus a, then the remainder is equivalent to p of a. Now, this one's a little bit different because the question is just going to be asked different, but you're still using synthetic division. So in this case, I'm given this polynomial x to the 5th minus 8x cubed minus x squared plus 2, and I want to find p of 3. Well, using the remainder theorem, what it says is I can take, if I divide this polynomial by x minus a, let's make this a 3, so that means I'm going to divide it by x minus 3. So what that means is I'm going to use synthetic division, but this time I'm going to use, this is the x value, that is the number I use outside the box, the 3, I don't use the opposite, and that's the big difference. Another key part to this problem, when I write my coefficients, I have 1 But notice there's no x to the fourth term, so I have to put the 0 there for that. Then the -8, then the -1, but there's no x to the first term, so there's going to be a 0 for that, and then 2. So now we're going to the synthetic division part. I'm first going to bring down this first coefficient, that's a 1. And then when I multiply that with 3, that becomes 3. Combine them, that becomes 3. Multiply, 3 times 3 is 9. -8 plus 9 becomes +1. 1 times 3 is 3. -1 and 3 combine to be 2. 2 times 3 is 6. 6 plus 0 is 6, and 6 times 3 is 18, and 18 plus 2 is 20. Now what I was asked to do was to find P of 3, and using the remainder theorem, it says if I use the synthetic division, I can find P of 3, it's going to be equal to the remainder. So P of 3 is equal to 20, and that's all I want. So depending on the question will determine what your answer will be. When I'm looking for P of A, and I'm using the remainder theorem, your answer is just the remainder. Where when you're dividing, you have that new polynomial that is your quotient. Okay, here are some U-try problems. Go ahead and try these, and we'll go over the answers the first thing. And your joke. Why did the geek turn on his computer on a hot day? He wanted to open the windows.